How does entropy generation influence power plant performance? Have you ever wondered how power plants manage the energy they produce? One key factor in this process is something called entropy generation. Let's break it down in simple terms. Entropy generation refers to the loss of useful energy during various processes in a power plant. This includes things like heat transfer, friction, and the movement of fluids. When energy is lost in these ways, it directly impacts how well the plant performs. At its core, entropy is a measure of disorder in a system. When entropy increases, it means that some of the energy becomes unavailable for doing work. This often results in energy being wasted as heat or through friction. In power plants, common sources of entropy generation include friction in machinery, heat transfer across temperature differences, and mixing of different fluids. So, how does this affect power plant performance? Simply put, higher entropy generation means more energy is wasted. This forces the plant to use more fuel to generate the same amount of electricity. As a result, operational costs go up, and the environmental impact increases as well. By minimizing entropy generation, power plants can improve efficiency and keep more of the energy they input for useful work. Engineers work hard to reduce entropy generation by optimizing various components of the plant. For instance, they focus on turbines, boilers, condensers, and heat exchangers. A practical example is maintaining low pressure in the condenser. This helps lower the steam temperature at the turbine exhaust, which increases the work output and reduces entropy generation. Another method is superheating steam before it enters the turbine. This raises the steam temperature, allowing for more energy to be available for work and reducing moisture that can cause losses. The conditions under which a power plant operates also play a role. Running the plant at higher steam temperatures or lower exhaust temperatures can increase efficiency. However, this must be balanced with the limits of the materials used and the associated costs. In real-world terms, reducing entropy generation leads to better fuel use, lower emissions, and overall improved performance of the power plant. Understanding how to control entropy generation is essential for making the principles of thermodynamics practical and applicable in enhancing power systems. By focusing on minimizing entropy generation, power plants can operate more efficiently, ultimately benefiting both the economy and the environment.